What does software engineering look like in 2 years and 5 years?
How come you're not broke yet?
we do make money. It's not that bad. Many companies stop hiring or slow down hiring of junior engineers.
They can rest in peace. No zombie world, no zombie land anymore.
Hello and welcome to the first episode of Fwdays Tech Talk. Today with you on this journey are Ivashchuk, lead software engineer at GlobalLogic, and Kyrylo.
Okay, so hi, I'm Kyrylo. I'm co-founder and CTO of Fwdays. It's a Ukrainian startup. And today here with us in this beautiful virtual room is Iulian Serban, who is co-founder and CEO of beautiful startup Korbit. Iulian?
Thank you, Kyrylo and Ina, for having me here. Yes, I'm Iulian. I'm the CEO and co-founder of Korbit. Pleasure to be here.
We're glad to have you here with us. And of course, as you are founder of Korbit.ai, for sure we'll start with maybe a short intro about the product itself. Could you please give us like a few keywords or maybe describe main concept of what is actually Korbit.ai and how we can use it?
Of course, it would be my pleasure. So Korbit is a generative AI agent for engineering management. And the main thing it does is code reviews. So when pull request comes in with sometimes 10, sometimes hundreds of files and thousands of lines changed, it goes through all of the code. It goes through every file, every line edited, and then it goes and it detects bugs. And so it can detect over 10,000 different types of bugs, from security vulnerabilities to performance issues to functionality issues. Is it behaving the way it's expected? Is there a mismatch here? All the way to architecture and design patterns, readability issues, logging issues, you name it. So it goes into the code, it finds these bugs, and then it helps the engineers to fix those bugs. And then it also helps the engineering manager with operational reporting. So there is a DevOps agent too that helps with generating release notes, generating one-on-one reports, even summarizing your tech debt issues, summarizing your security issues, and so on. And so it helps the manager of the team also be more effective.
Sounds great. Sounds like a really useful tool for everyone in engineering, especially engineering.
It definitely is, yes.
Doesn't matter you're a software engineer or engineering manager. So that's good. And of course, like my next probably expected question, what has inspired you to start your own project, Korbit.ai? Have you got this idea? And that's...
Yeah, I would love to share that story. So years ago, I did my PhD in AI. I worked in generative AI before it was called generative AI. I worked on deep learning systems, building systems that could do dialogue, do conversations with users. And I built over a dozen different systems for conversational purposes like tech support, customer service, and even entertainment. And so I built a lot of these systems. I published many papers. I co-authored a book. But then at the end of my PhD, I did not want to go and work at a large corporation like Google or Amazon, although definitely the benefits and the salaries are attractive. I thought I could do something which for me would have a bigger impact. And I thought that place could be the future of work and upskilling. And so I started Korbit with this vision to change the way that people train and learn on their job. And so it was an ed tech startup, an education technology. And the idea was to use machine learning, use deep learning, generative AI to transform how people learn skills online.
I remember that the first version of Korbit that I've seen 2 years ago were absolutely other startup, it was PR reviews, but the main idea was to teach your engineers to not do the same mistakes again. And you had this learning center inside of the platform.
That's right. It was a learning application. And so we were teaching Python skills, data science skills. We had 30, 40 different modules or courses to teach the engineers. And so that's really how we started. And actually the product was an AI teacher so that every employee, every student could have their own AI teacher. We built that and we grew it to literally 20,000 students and engineers using it. And so there was a lot of interest and people were using it to learn lots of skills, but it was hard to monetize it. It was seen as a nice to have, and really the biggest pool of users were from universities using it as a free product. And so we ended up pivoting to enterprise. Let's help the companies who can also afford to pay for it so we can build a business around it, and let's help them in their workflow. And so we went through lots of experiments, lots of pivots, and then finally you see the product we have today.
Sounds interesting, like really interesting journey. And of course, as you just mentioned that you start selling it and for enterprise projects, do you have communication or feedbacks that you collecting from some company that are using Korbit.ai, and how you actually manage it? Because probably there could be a lot of stuff going on.
Yeah. Do you mean like how do we collect customer feedback? What's the feedback cycle back to product? Yeah, this is one of the hardest things I learned while building the company, especially when we started in the education sphere, because every time we talk to an engineering manager or a VP or a CTO and we ask them, do you want to train your employees? Do you want them to learn more skills? They always said, yes, we want them to learn more. But actually they did not want to give the time or the money and the resources to do it. And we saw that, often what people say they want is not what they actually want, especially in a nice to have context like education. And so what we realized through many conversations was what really keeps the engineering manager up at night are the bugs, are the security vulnerabilities. It's being late. We're 2 weeks late shipping this, or we're shipping tomorrow and I know we haven't tested it yet. That's the thing that makes them not sleep at night. But it took a lot of time to get to that. And so we learned a lot about, I learned a lot personally about how to conduct good interviews, product discovery and design thinking with these people and understand what they really mean instead of just what they're saying. Another problem we often faced was, just to give you another example, is there are engineering managers where their teams struggle. Like they don't have the right skills, they don't have the right level, they're shipping buggy software, but they're not going to admit that, right? They're not going to come in and say, my team has problems. They try to be positive, they try to look forward, and so it's hard to really figure it out. And then sometimes if you have group calls with the engineers, of course, they won't talk like that anyway because they don't want to cast blame, they don't want to sound negative. And so it can be very hard to get the real problem out of someone. And especially in this kind of field where there's so many humans involved, it's a team effort. It's just a lot of human psychology, really.
Yeah, true. Also, what I've noticed at many projects that sometimes there is even no available people who could do code review. That's really painful things, and of course, some features can be postponed due to that fact, or even worse situation when there is no seniority level engineers that can do and really check if code is correct, if there is no vulnerabilities or maybe some performance issue. Like no one who can catch that during the code review process. That's true. So
yeah, we've seen a lot of companies that just struggle to do code reviews. They don't have the time, or they don't have the senior engineer, or they have one guy. It's usually a guy, and he's just busy with 10 other things. And then also code reviews are brutal. Like sometimes you get a pull request with 100 files, like 10,000 lines change. Like how can a human go through 100 files and think through all the potential bugs, the security vulnerabilities, think through all of this? It's kind of like, it's an inhumane task. And so, it's a really hard task. Companies don't have the resources. It's painful. And what you end up getting is like bad code reviews, or people just don't pay attention. They spend 20 minutes and then they stop. And you can see like their attention stops after about 20 minutes or so.
And yeah, I'm feeling this problem for sure. And we had at my previous project, we tried to build a code review culture. So in case someone creates pull request, then more than even 2,000 lines of code, so it wouldn't be reviewed, and it should be split into smaller pull requests into feature branch. So that's like. Also, one
that's
thing
a good practice.
Can be, yeah.
Did it work out?
Yes, for sure. And nice. We, of course, we make some jokes or some even special badges to nominate someone who is like doing good or bad things. So yes.
Okay, nice. You had like an employee of the month, like best code review.
Yep. Kind of, but it was, of course, it was in polite way, nothing rude or anything like that. But just, hey, we don't want to review your 100 lines of code pull request. Please split it. Of course, it's possible. Usually, it's possible. Sometimes it's really complicated, but usually it could be done for sure.
Yeah.
And also, I remember I've used really for a short time Watchdog tool. It's kind of helpful tool to do like first round of code review, but it I don't know, it may be a bit similar to SonarQube that just scan your code and maybe can find some really big problems or something like that. Have you tried those tools, or do you have?
Yes, we've tried SonarQube. We've used it internally. We have our own CI/CD pipeline. We use something called Vercel. So we have them. They can be also very useful. We work together with those tools. Most of what these tools help us with is like running automated tests, running our unit tests, our integration tests. They help us check dependencies. They help us monitor also in production, monitor bugs and stuff like that. But they don't catch the more complex bugs that are inside pull requests, especially sort of sneaky, insidious bugs that this thing is calculated the wrong way. So now all the customers get charged 50% more, but it doesn't crash. So that kind of bug wouldn't be caught here. But there's definitely, there's many tools, and you often have to pick the right combination.
Yeah, right. And Kyrylo, do you use such tools like that at your project?
Yeah, we use Korbit.ai as a tool to review our pull requests. But of course, we try to use Sonar, but Sonar Cloud with our code base is really, really hugely expensive. Absolutely a massive pack of money we need to spend on that to run it on all of our code of all of our repositories. So we pushed back from it. Also, we use Snyk for automatic dependency reviews and automated pull requests regarding dependency reviews. But mostly we use our corporate culture of code reviews, or each and every code should pass the review of peer, and after that the same pull request goes to the senior engineer who approves it and give it a try to go to rollout, and after that we use this canary deployment, etc. But this is not a kind of a topic of our today's conversation. This is more about CI/CD part. So yeah, something like that. And Korbit saves us a lot of time, but let's talk about that a bit later.
I have another question. Of course, CI/CD is not part of this conversation today, but what should be a part of this conversation is high level of architecture overview of Korbit.ai, because that's really interesting. Currently, there are really wide range of technologies that we can use to build AI tools. So I'm wondering, how do you build it?
You mean, how, like, what's the architecture behind Korbit?
Yes. Yeah.
How does it work? What's the secret sauce?
Yeah, without secrecy. Or it depends on you. If you'd like to, you can share, but...
Yeah. I mean, I'm happy to share the high-level picture, of course. So it's an agentic system. Korbit has, in fact, there's many agentic systems inside it. So the way it works is when a pull request comes in, let's say you have a PR inside GitHub, we grab all of the files in that pull request. We grab all the code, we grab all the metadata, and then the first thing we do is we summarize what is being implemented. What is the feature or the bug fix or the refactor being implemented? We summarize it. We have a short version. We have a long version that's pages long. And then given that context of what it is that's being implemented, then we go out and we grab more context. So we have a dependency parsing that runs, and it goes and extends the context window. And then what happens next is we have a set of agentic systems that go in and look for certain kinds of issues. Like we have an agentic system for security issues. So it goes and looks at all the files that were changed, all the diffs, all the hunks, and then looks for literally thousands of potential security vulnerabilities, from SQL injection attacks to authentication problems, all the way to using an unsafe library or an unsafe mechanism inside an API call. And so it looks at all these potential issues and then starts identifying. So you get huge lists of security issues. That's just one of the agentic systems. There's 7 others for other kinds of issues. There's an agentic system for finding functionality issues, seeing if the API, if the class, if the function is behaving correctly. There's an agentic system for finding performance issues. There's another one for finding readability and error handling issues. There's another one for finding design and architecture issues, and so on. And so all these agentic systems, and I call them agentic because the definition of agentic is a bit fuzzy, but in this case, they do go around the code base and they identify issues, and they have certain actions they can take, and they have a memory, of course. They go and do these things, they find the issues, and then we end up with a huge list of issues, sometimes hundreds of issues in a pull request. And of course, we don't want to show all these 100 issues to a developer, so then we have another set of agentic systems that filters and takes away all the irrelevant, all the useless stuff that you don't want to see. So for example, we have an agentic system for finding hallucinations. So it will look at an issue that was found, let's say a security issue we detected, and then it will jump around the code base and check, is this a real security issue or is it not? And it will look at, for example, the call stack and other files to try to investigate, is it a real issue or is it a hallucination? We have another system for finding coding standards. So maybe we say, oh, you're missing a logging statement over here. But then when we look at other files, this system can look at 20 other files. It will go and look. And if it sees, oh, this is how you do logging, this is how you do logging, this is how you do logging, maybe it concludes that this is not a real logging problem anymore because you're logging in a different way somewhere else. And so we have a whole set of, I would call them filtering systems, verification systems that go in and remove the less useful issues, removing the hallucinations, removing the low value issues. And then finally, there is a recommender system that, like there's now at the end of the pipeline, we have a much smaller set of issues, but still we could have 10 or 20 issues. The recommender system goes in and then it decides which issue should we rank at the top and highlight and which one should we suppress. And so it learns from the past behavior, what issues you fixed last week, last month, 3 months ago, which issues you didn't fix. It learns from also the standards in your repo. So it reads around and tries to understand how relevant is it? Is it within the context of the PR and so on? And then it makes a decision around what to show you. And so it goes like every time we run a pull request scan, it goes through all of these agentic system. Usually takes a couple of minutes, and the end result you see is the PR review that comes out of it. And of course, that system improves with every PR because we learn from the data. We see you fixed this issue, but you ignored this other issue. That feedback is fed back into the system, and so it keeps getting better and better and better.
There's many requests to have like on premise. I know someone is really scared to lose the sensitive information or maybe some algorithm and so on and so forth. Is it actually a case to have it like on-prem, somewhere running somewhere on clouds or on own servers?
That's a good question. We've had customers ask about on-premise solutions. For sure, we're talking to a very large one of the largest banks right now about this. And some companies just have a requirement even for legal and compliance purposes. But with our cloud solution, we're SOC 2 compliant. As soon as your PR scan is done, we delete all the source code. We don't store it. As soon as it's done, we throw it away. And then the providers we use, OpenAI and Anthropic, we have a 0-day data retention policy in place so that they delete the data after 24 hours at most. And so we have all these things in place. And for, I would say, 90% of companies, that is more than enough. It's more than enough for any SOC 2 compliancy. But there are extreme cases like really large banks or government institutions that really need it to be fully on premise.
As usual, they have more rules, more
bureaucracy.
Exactly.
Yes,
more
more
red
bureaucracy.
tape.
I have two questions here. So first of all, you told that much of agents, like that much of context, enormous context window. How come you're not broke yet? I mean, you charge a really small amount of money per developer, per company, and still you're reviewing unlimited lines of code, and each and every code to Anthropic or to OpenAI costs money. And I can imagine the size of tokens is just enormous. How come? How come you make money?
We do make money. It's not that bad, but the system is intelligent, and so it doesn't do unnecessary scans of things it doesn't need. So we've optimized the system so that it has the right context to do the analysis. That helped a lot. Depending on the task, we use different models. So some very simple tasks, we can use a turbo model, for example. There's GPT-4o, there's a turbo. The cost of these is much less. And then, of course, the cost of LLMs have been dropping. It's almost a 10x decrease, right, in the last 18 months or so. So the costs have been dropping. But yes, to be honest, last year we were losing money for every new customer, but it was in a sense an investment for us. And now we are making money for every new customer. So that is good. And I think that is part of the game, right? When you're building a new product, you launch it. If you try to make money on day one, you're limiting the space of solutions. So instead, we were focused on finding the right bugs. Let's find the bugs that are most critical. Let's create value, and then we can optimize later. And that's exactly what we did. We put a lot more effort in optimizing later. And then the prices kept dropping. And so we don't have to worry that. I mean, we have to keep an eye on it, but it's really not a big problem. And I think as time goes on, we will optimize a lot more. Prices will keep dropping. We will probably start increasing the price because we see customers, they pay $12 a month for one developer, but we catch a bug that saved them literally $10,000. And so it's a very easy argument to go to Mr. Engineering Manager and then tell them, hey, you saved thousands of dollars, like, would you maybe pay double for this service or triple for it? And I think the answer is usually yes.
Yeah, definitely. Yeah, nice. Good to hear that you are profitable already. But the second question is a bit more technical, tricky. I don't know how to say that. Yeah, go ahead.
Oh, Kyrylo, I just want to clarify. We're not profitable, but we're making money per customer more than we're spending in LLM calls. But I'm still in a startup mode where we lose money every month on average because we have employees and many other expenses to pay, of course. Sorry, go ahead.
No worries. So the second question is a bit more technical or more tricky. So how do you think why different languages or different ecosystems are really different each of one of another in case of code reviewing, in case of writing code using AI? For instance, Claude or Cursor writes perfect code for me in Golang, but really shitty in TypeScript. And sometimes it goes circles when I try to fix some bug or find some bug. I'm not a front-end engineer. I'm a back-end one. So I run these tools to do some kind of front-end for my pet projects or for my startup. But the same is with Korbit. When we review our backend code in PHP, in Golang, even in Node, it goes okay, even great in Golang. But when we're talking about TypeScript, sometimes it goes circles the same. But funny thing, when I write the code using Cursor, upload it to GitHub, creating a pull request, and after that we see this war between different AIs because Cursor wrote me the code. I upload it, and after that, Korbit says, "This is wrong. You should do it differently. You have bugs here in your code."
That's interesting. Hopefully, they're together creating a better pull request.
Exactly.
I think one of the things, like we've seen the same pattern. But what's interesting is actually the TypeScript developers are telling us that our code reviews are very good in TypeScript. It's one of the languages we do really well in, and so maybe the way we designed the system and the many benchmarks. So we have a suite of hundreds of benchmarks, pull requests we test against. We have a lot of TypeScript in there, and so we go and test against open source TypeScript libraries, TypeScript web applications, and so on. So maybe we've just done a really good job at nailing it. But I think the other thing that's happened is if you take the LLMs, what they were trained on, right, was like hundreds of millions of open source repos and projects across these platforms. And you need to look at the quality of that code and where it came from. So in a lot of the more back-end centric languages like C++, you would have computer science majors, like very technical people who were schooled in good software design and architecture, algorithms, and they had to deal with pointers and parallelization and threading and all that crap. And so they wrote really high quality code, but in the web development sphere, you had a lot of people come in with no degree, just learning on their own, or even coming in with a 6-month, 12-month, let me learn web development online. And so that whole community is, for better or worse, they build a lot of stuff, but they don't come from the same school of thought of software engineering. And so the quality of the code that these systems were trained on is probably very different. And also the kinds of applications you build are very different. Many web applications are much simpler, and they don't require you to understand pointers or parallelization necessarily. So I think that just the fact that the input distribution of data is different is why these, your average LLM model will generate the average piece of code you find online because that's what it was trained on. Of course, there was reinforcement learning as well on top of it, but that was the base that trained it. So I think that has a lot to do with it. With that said, I do think the TypeScript developers also find a lot of value in Cursor and other tools, even if it is it's still saving a lot of time. It's still a very useful tool in these languages.
I can prove it for Copilot for sure and TypeScript. because I had a lot of experience writing code using Copilot, as GitHub Copilot, of course. So I haven't tried Cursor, but I'd like to, because yes, that's become more and more a popular tool. And as I can see from different feedbacks, it's even better than other tools, comparing to other tools. So yeah, definitely would like to try. And as you mentioned about web development in general, that there are people who are coming like from just 8 months or 3 months courses or trainings or something like that. There is even labels or positions like React developer. And when you ask them, what is actually function or what is object, they can't answer because they don't have basic knowledge. They start directly learning Vue or React or Angular and nothing beneath it. Like, yeah, that's a big problem for sure.
I think it's a time to talk about the team.
I have that question in my mind. What qualities or skills do you look for when hiring team members at Korbit.ai? Because that's really tough topic probably, but really interesting.
Yeah. That's a great question. So we're a small startup with about 12 people, right? So you have to hire people who are, first of all, very intelligent and very generally capable across many roles. There's no such thing as I only do X, right? Those people won't survive in a startup very long. You have to hire generalists or people who they may have a core skill, but they can expand from there. So I would say general intelligence and then adaptability and willingness to learn. So, okay, I used React over here, but now I have to learn this new framework in this company. That is really important in a startup, and there will be new things almost every month, especially in this field. There's new tools, new AI tools coming out like all the time. So you have to be very fast at learning and adapting. And then one thing we found was very important is to avoid big egos and people who think that they know better. We're living in a world of sort of unprecedented change. Things are moving really fast. And if you come in thinking, I have the answer, I am right, then you're almost certainly wrong and you're not going to change your opinion about it. And this is, and unfortunately, that's often a trap for more senior developers. If they have maybe built many applications successfully 5-10 years ago, they come to a startup now and they try to do the same thing they did before. That's not going to work. Or maybe it works, but it's much slower, or it's going to use an outdated tech stack. And so I have seen sometimes you can find people who did very well a few years ago and now are senior, but are not willing to adapt and maybe have built up an ego. And so I think that's one of the things to watch out for. You want humble, nimble people who are very smart and learn very fast and who adapt. And then, I mean, there's stuff specifically around ML that we look for. One of the key things, like I said, we have a whole pipeline, a system of agentic systems inside, and we run, not only have we built all these agentic systems, but we build our own tooling around it too. We build our own evaluation pipeline with literally hundreds of pull requests that we scan against on open source repos and libraries. We build our own annotation schema. So we evaluate everything. Every issue gets evaluated across factuality, actionability, scope, severity, whether something is a severe issue or not. And so we build out this whole infrastructure and tooling. And that's one of the things we care a lot about. So it's not just building a product that works, but building the best in class product, the best quality, the best code reviews in the world. And so we when it comes to hiring, we focus a lot on the engineer's ability to frame the ML problem. Can they articulate what is the problem they're tackling, why it matters, how to measure that we're making improvements, how to evaluate, how to think about the confounding factors around it. Can they go through all this, establish their methodology and evaluation metrics? If they can do that, then they would be a good fit for a place like Korbit. That may not necessarily be the case for other companies, but this is very important at Korbit because it's really key to the way we build our product. And it's the reason that we can build such a great code reviewer in the space.
And of course, there will be the following question. If there is someone who just wanted to start their software engineer career, what would you recommend to learn? Probably computer science.
That's a good question. I mean, in a way, it's the most exciting time in the world right now to go into computer science, but it's also the scariest time, right? Because what does software engineering look like in 2 years and 5 years? I think what I would suggest is to learn the core principles of algorithms, of good design, of software architecture, but then also be a generalist and learn across different fields. Because I think in the future, a lot can be achieved with generalists. You don't need someone who's just a React developer. You don't need someone who just manages AWS instances anymore, because AI has made it so much easier. You need generalists more, but you also need very capable generalists who also understand architecture. And so you probably need some core fundamentals, but then you go out and spread out. And then I would say, I mean, the other trend we're seeing is, product engineering or product management is going to be increasingly important. So engineers don't just have to build stuff. They also have to understand what they're building, who they're building it for, what value it creates, what problem it solves. And so they have to be a blend of engineers and product managers. Some people have started to call that product engineering, although it's a little bit fuzzy, but I think trying to understand that is going to be important.
Do you think that in the nearest future, this product engineering will be a combination of product engineers and prompt engineers, where these product engineers will code themselves a solution using just prompts and understanding of a business model, of the value of customer, etc., just prompting the MVP and presenting it to the customer or to the company inside of or whatever, without any engineers themselves?
I think it's possible. I think it depends on the kind of application you build, right? So
yeah,
if you think about a system like Google that has to process billions of requests every day, you'll probably still need some very specialized C++ engineers who can fiddle with the buffers inside the key system. But maybe for many, I would say, relatively simple web applications, maybe this is exactly what it looks like. I think it depends on the segment. Or maybe the tools would just be so good that if you're the customer, you want to build something, you just go and use a tool and it just does it for you. And you don't have to hire people to do it really at all. You have a problem, you want to build something, you just go build it yourself if it's a very simple thing. I think that's a bit the trend we saw with WordPress and like blogging some years ago, that now anyone can set up a blog in 5 minutes. I think we'll see a similar trend with many other applications. I also think the prompt engineering role is kind of a misnomer, because we're all prompt engineering all the time now. Like, we're all writing prompts to LLMs. So I don't know if there will be a dedicated role just called prompt engineer.
Yeah, but talking about this WordPress thing, we still have thousands, dozens of thousands of these WordPress agencies who build you this WordPress website or blog, etc., etc. So I think that the main problem is that customers and users, they are not very good in explaining what they want. And they cannot explain it usually to people. Why we think that they could explain it to LLM? Oh, I know the solution. Neuralink. Yeah.
Neuralink, yeah, that's where we need to go. I do think the fact that it's so fast, right? You tell the LLM, build this, and then 30 seconds, 1 minute later, you see the result, allows a very quick iteration, and that helps. Even if you don't quite know what you want, you see the result, you can iterate. I think that helps a lot. I don't know if it solves it entirely. Yeah. But it's an interesting question. Go ahead.
I have a question here regarding this development. Ina asked about what to do these non-engineers who just want to be an engineer. But I have a question. What do you think how our world will look like in 3-5 years when right now senior engineers, they don't already need a lot of junior engineers to do monkey job. They can ask Cursor, Windsurf, any other tool or AI itself to build this job for them. And so we have seniors, we have middles who more or less will become seniors in a couple of years, but juniors not get hired, that get fired, and no juniors are needed anymore. So who will become middle engineers? Who will become senior software engineers? How come? Yeah. What will be?
Yeah, that is a big problem coming up. We're seeing the same trend where many companies stop hiring or slow down hiring of junior engineers. That's for sure happening. And as you call them, the monkey jobs can be given to Cursor or other tools. So I don't know. I do think this distinction of senior engineers versus mid-level versus junior, I don't know if it's the number of years of experience. Once you have 2 or 3 years experience, it starts to be more about your intelligence, your ability to think abstractly and think in systems and algorithms and architecture. And then whether you have 15 years experience or 5 years experience, in my book, doesn't really change. In fact, if you have 15 years experience and you come in asking for a high salary and there's many jobs you don't want to do because that's a waste of your time and you have a big ego, now that experience is becoming a liability instead of a value add. Not always, but I have definitely seen people in that box. And so I don't know if the right metric is seniority. I think the right metric is capability and intelligence. Can you think about these? And I actually think, a student coming out with a computer science degree and 1 or 2 years experience could get to that level. If they work hard, if they have the intelligence, they could get there. So in that world, maybe the gap between senior and junior is not that big. There will just be a new cohort of people who they're just so much better at thinking abstractly and solving really hard problems that they work very well with the AI tools. And anyway, they can solve the monkey problems just by asking Cursor to do it. And so those people will come in and be the next generation.
I told about this 2-3 years. It's not about the difference between middle and senior. Maybe I told my point wrong. This is about the 2-3 years of AI and its capabilities, which are improving each half of a year, I could say. But the problem is, of course, you can have really, really intelligent last year graduated student who can think and solve problems better than any senior software engineer in your team, but they don't have experience. And our LLMs, our AIs, they glitch. They hallucinate, and you need to have an experience to understand that this is hallucination. I will not take this advice. I will rephrase my prompt or do something by my hands, etc., etc., etc. So that's the problem, as of my point of view. Okay.
So, and my next question will be related partially also to previously discussed topic. Currently, I'm with some software engineers that do not accept any AI tools. What would you tell them, or how would you argue them to start doing it?
It's true. I mean, we've encountered software engineers who do not want to adopt AI tools, or just are very skeptical. Mm-hmm. I think it's changing fast, though. We do see developers are initially a year and a half ago, many were skeptical, but now everyone's sort of seeing the change. And I think the most powerful thing is when you try it yourself. Just give it a try and you'll start learning, and you'll find your own way of interacting with them, your own favorite workflow. The other thing that happens a lot we've seen is they see their colleagues doing it every day. And if they sit together or they do a screen sharing session, they can see it. I think those are probably like give it a try or see how your colleagues do it are the most obvious ways. I don't think you can really force people to use a certain tool unless it's like a compliance thing. Like we all must do it this way, and it's hopefully a small part of your workflow. But most engineers want to find their own way to use the tools, is our experience.
What kind of tools do you use in your team, like extra AI tools?
Oh, yeah, good question. We use Cursor. Some developers use Cursor, others use Copilot. We also use tools like inside Datadog. We have access to AI tools to help us do better analysis of our log files. And then for some of the R&D work we do, we use Replit and the Replit agents in there. And we have essentially like Jupyter notebooks for running experiments. So we use a variety of these. Most of them are in code generation. And of course, for code review, we use Korbit ourselves. And then we have some monitoring tools to use it. I think we're still experimenting. We experimented with Devon and found it was not helpful for our kinds of projects. We experimented with a few other tools as well. Then they were not all useful, but we keep trying them. And I think a strong, modern, state-of-the-art engineering team is always experimenting. They're always trying new tools, like literally every month. And developers who are at the forefront will come to their team and say, oh, I discovered this tool. Do you want to give it a try? And so it happens kind of naturally.
Yeah, finalizing our topic regarding the future of AI and future of engineering, I would love to ask you a question. How do you see what world, what developers, engineers, product managers, everything in collaboration, including development and shipment, will look like in 3 to 5 years, looking at how fast our AI tooling is growing? Who will write the code? Who will deploy it? How all the process of working from requirements till the actual shipment will look like? What do you think?
I think a lot of it will be AI will write the code, AI will review the code, AI will deploy the code, and humans are at a layer above orchestrating that. I think you will have at least 2 segments of applications. One segment will be like very, very complex applications like search engines like Google, or maybe financial banks, that you have very strict requirements on the logic and performance of these systems. And you have engineers like writing the code. Maybe they're sitting and writing C++ code, or maybe if you think about embedded systems like devices in self-driving cars, they're writing that even C code that has to be very performant and meet many standards and compliance requirements. And then I think there's going to be a segment of humans doing that with AI. And then there will be another segment of low complexity applications, many web applications, many consumer applications, where the AI will basically write 99% of the code, and humans will orchestrate it, and they will do the product management and product engineering around it. And maybe a single person can actually build the entire product and deploy it and maintain it. I think we will head into a world like that. And I think the first one, where it's very complex solutions and you have like on-device code, I think those engineers have to be really smart and very capable, especially technology-wise in terms of algorithms and design patterns and architecture and all this. The product engineers that would work in the other stream over here would be probably much more user experience oriented, and they would be more generalist because maybe the performance doesn't matter as much. Maybe it doesn't have the same compliance restrictions, but the products that win in that category still have the best user experience and the best value to customers. And so they need to be really good at delivering that. And so I think we're going to head into a world like that. Maybe there's things in the middle too, but I think the world would look like that. And then in that segment where it's maybe one person or maybe a few people building the entire application, launching it, deploying it, like the AI will write almost all of the code and humans are just supervising at a high level. And I don't even know if that's 3 years out. It could be just a year or two out. It's a little bit hard to anticipate. I think the other thing that happens in that segment is because it's so easy and cheap to write code, you can write garbage code and you can throw it away again. It's the same thing that's happened with many other things, like it's cheaper to buy something new than to repair something old, we find often in our society, and the same thing will happen with code. Like maybe we have this legacy code from the 90s, but we can rebuild the whole thing in a week. So why would we waste months rewriting and maintaining legacy if we can just build a new version? And with the same logic also, I think you get a new type of paradigm where people the quality maybe goes down overall. You get a lot of junk code or cookie cutter code, and it's okay because you can rewrite it again in a few days or even a few hours. And so I think we get to a world where that happens. So I think that will definitely be the case for many new applications.
So you really think that we can let these old COBOL developers die? So rest in peace.
I didn't say that, but yeah. I do think a lot. I mean, we're seeing large enterprises with legacy codes. Some of them are starting to modernize their stacks, and I think it will become much easier. Like, let's say you're a big bank and you have a lot of COBOL code. Maybe it would have taken you 2 years to modernize it, but maybe now it takes you 2 months. Why, as a bank, why wouldn't you put in that investment to renew the whole thing? And you can't even hire your COBOL developers anymore. Plus, they're super expensive. Plus, you have a bus factor 1. Plus, no one really understands the old code. So it's a huge security risk. It's a huge compliance risk just to live in that world. So why, if we can now rebuild it very fast, why not? But I think that's probably going to move slower. But I do think a lot of the web applications and low complexity applications will definitely move very fast. They will move away from legacy code, and they will just write low quality code, but it will just work. And people will then throw it away and they will write it again if needed. I think this is a process you go through when the cost of development goes down. This happens in many different places. Like as soon as it gets cheap enough, people just want to throw it out and do it again.
Also, what I've noticed, lately, there are many companies that has this legacy code. They are looking for some AI tool that could help them, for example, migrate from some old Java version to the latest one and fix all problems in their code, especially related to security and so on. So yeah, that's also the case. And yeah, for the moment, I'm not sure if there's really a lot of tools that could help with that fully and generate, for example, end-to-end integration tests to fully rebuild from scratch, using a legacy code and building the brand new code. So yes.
Yeah, and if you think about if you have a legacy code base that's running, you can give that to your AI agent and it can look at that and rebuild it. And if you have test cases, you could run those against a new code base, and you can have the AI generate the test cases on the old code and then rebuild it in the new code base. Those things are going to get increasingly easier. I don't know if there is a future for COBOL developers in a few years.
They can rest in peace.
But who knows?
No zombie world, no zombie land anymore.
Yes.
Right.
Yeah. And on this joke, I want to say thank you to Iulian. Thank you for having us here and answering these questions. That was really, really a big pleasure to talk here in this virtual studio. And for each and everyone who look at us, who watch that, please like, subscribe, and wait for new videos. Thank you.